Apollo 16 astronauts rehearsed today for Sunday's scheduled moon launch. The television pictures they send back to Earth from the flight may be dramatically superior to previous transmissions, as Bill Curtis reports from North Hollywood, California.
When Apollo 15 prepared to blast off the moon's surface in August 1971, viewers saw this picture, remarkable at the time. Now advancements enable us to see this picture. It is called image enhancement. With a picture so free from interference, scientists can study the planet over television. For instance, when NASA officials saw this enhanced version of the blastoff, they discovered a few extra parts flying around they hadn't seen before. The television picture is electronically taken apart and then by computer put back together much clearer. It all happens at a young company in North Hollywood, California, Image Transform Incorporated. Apollo 16 pictures will travel from the moon to California's Goldstone Receiving Station, to Houston's NASA headquarters, back to the small building in North Hollywood for enhancement, then again to Houston for the world to see, all in less than a second. Compared with the multi-billion-dollar NASA facilities, these offices could fit in a broom closet. And that's about where the young company is keeping its secrets, but the product sells itself, turning round images into distinct rocks and crevices. NASA signed a contract with the firm 24 hours after they saw these results. If all goes well on Apollo 16, it will be hard to tell the difference between simulation and the real thing. Bill Curtis, CBS News, North Hollywood, California.
Moon or no moon? Yes, folks, what we have here is supposed to be a photo of our moon taken by a human being standing on the Earth, pointing his camera and just pressing a button that made a sound click. And folks, as well as showing no sign of Photoshop interference, bring it up and we've got no square box around the moon. And here you are, again, no sign of any square compositing box around the moon. And here is another, and as you can see again, brightening up, no compositing box around the moon. And again, no sign of photoshopping. And what we have here is a photo supposed to be taken by an astronaut named Neil Armstrong, standing on the moon and looking at the planet Earth in the distance. And wow, look at that when brightened up, folks. The Earth is in a square box. And what about this one, folks? Supposed to be taken by an astronaut on the moon? And just take a look at the wee little Earth in the distance. And not only that, it's been photoshopped. What do you think of that little Earth, folks, compared to the size of this moon taken with a camera? And what about this one, folks? Supposed to be taken from inside the LEM, Mother Earth in the distance. And look how wee that is, folks.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win.
It's one small step for man, one giant leap for mankind.
For the 1990s, space station freedom, our critical next step in all our space endeavors, and next, for the new century, back to the moon, back to the future, and this time, back to stay. And then a journey into tomorrow, a journey to another planet, a manned mission to Mars.
Return to the moon by 2020. We will then be ready to take the next steps of space exploration, human missions to Mars, and to worlds beyond.
By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow. And I expect to be around to see it.
And return American astronauts to the moon, establish a permanent base there, and develop the technologies to take American astronauts to Mars and beyond.
But despite these grandiose visions of building lunar outposts or landing people on Mars, human spaceflight has remained confined to low Earth orbit since 1972. NASA's latest initiative, the Artemis program, proposes returning astronauts to the moon's surface by 2024. A mission to Mars may then follow sometime in the future. Will things be different this time? What is standing in the way of NASA achieving these goals? And ultimately, will we ever get to see NASA land people on Mars?
In June 2011, Ron Guerin found himself facing that danger firsthand.
I was maybe 4 months or so into the mission, and we got a call from Mission Control that a piece of space debris was going to pass a lot closer than people wanted. If we know about it soon enough, we will change the orbit of the space station. We can boost it up higher or lower and change it so that we avoid that object. But for whatever reason, this one caught us by surprise, and we did not have enough time for us to be able to move the orbit of the space station.
With the astronauts staring down the threat of a collision, they're faced with only one choice: abandon ship.
The International Space Station has several different ways of trying to deal with potential collisions, but the last-ditch defense are the 2 Soyuz space capsules, because those are basically lifeboats.
Ron and the crew race to the Soyuz capsules. Now, the only thing they can do is brace for impact.
And then it was just a waiting game after that. But we didn't know if it was going to hit it or not.
NBC's Jeff Rawson watching all of this. Jeff, good morning to you.
Space junk was on a collision course with the International Space Station. Spotted so late, there was no time to move out of the way. Instead, the 6 astronauts got the order from Mission Control.
The probabilities are still in the red threshold, and we are planning to have you shelter in place.
If all else fails, the astronauts on board the space station can climb into those Soyuz space capsules and wait to see whether a collision actually takes place. If it does, they can in a few seconds detach from whatever's left of the space station and then immediately try to return to Earth.
When the object passed the space station, we got a call from Mission Control that it was all clear. And it turned out that this object passed within a football field of the space station, and relative velocity was 8 miles per second. So it's a fairly large object traveling that fast. It probably would have destroyed the space station had it hit. There is evidence of hits on the space station, and a little piece the size of a grain of sand that really make a bad day. It's something that should be a major concern if we're going to continue to use the environment of space for the things that we want to use it for.
The Earth's atmosphere is a protective shield for anyone on the ground. But in space, there's no escape from the power of the sun.
Solar flares and other kinds of violent eruptions from the sun are very, very dangerous for anybody who's in space. The amount of radiation that suddenly is pouring off of the sun at that point jumps way up. And we can try to create certain kinds of very shielded areas that the astronauts can hide in, but even those can only offer a very inadequate protection against the level of radiation that the sun can suddenly release at those times.
An extremely powerful solar storm could send the crew looking for cover.
What we would do is we'd find a place on the space station that offers the most protection. Water turns out to be a fairly good insulator of radiation. We do have bags of water on the space station, and we'd probably huddle some bags of water into a location and get behind that as best we could.
But in spite of that danger, the same powerful burst of energy also gives the astronauts on the space station front row seats to the greatest light show imaginable.
The auroras are just incredible. And there were times on my mission where we flew so close to the auroras that you could reach out and touch them. I mean, they were going right by the windows. It was absolutely incredible. The pictures really don't do them justice. They really do dance.
But what you're seeing, really, is the after effect of a tremendously energetic and dangerous solar storm. These subatomic particles screaming across the solar system at just under the speed of light are getting swept up by the Earth's magnetic field and funneled down into our atmosphere. It's humbling and amazing.
An explorer is about to land on Mars, looking for answers. A make-or-break moment for a very expensive robot.
This seems crazy. Why again does this work? If it doesn't work, it's kind of a bad day on Mars.
Adam Stelzner, an engineer from NASA's Jet Propulsion Lab, has some explaining to do.
I am terribly humbled by this experience. I, forever, secretly, have felt that I do not deserve to be in the position of leading the team that I lead.
Adam, tell us about the landing.
All right, Greg. I can't tell you too much about it. I mean, it looks good. I'm being a little flip. In short, it looked extremely clean. We touched down in conditions that were on the more benign side of our nominal expectation. This is preliminary data scooped with the sieve in the cacophony of the control room during the celebration. Right? And largely by my good friend Miguel San Martin, who's somewhere out there. Our powered flight appears to have been excellent. If my good friend Ben Toma is in the house, is Ben in the house?
I have to ask you, what kind of file type? Can you tell us about the image file type and compression that was used to send this very important couple of thumbnails back from Mars?
Yes, unfortunately, I absolutely cannot. If Justin Mackey is in the room, or there's a couple other people on the team who'd be able to whip that out quickly, but I couldn't tell you.
The unmanned spaceflight website has coordinates for the landing that go down to something like 5 decimal points. I just wanted to confirm with you that you do have those sort of coordinates. And am I reading those coordinates correctly when I see that it looks as though you landed within 500 meters of the skirt around the mountain? That, I mean, you're really very close to the mountain at the closer end in the landing ellipse, and possibly within striking distance of the phyllosilicate trench.
I can't confirm that. I'm looking for somebody. Yes, there's somebody in the audience here who has that in the tip of their noggin. We should have soon that estimate, but I don't have it to 5 decimal places. We wouldn't report it to that because we're certain that we don't know it to that. And I don't know what the unmannedspaceflight.com estimate is.
Can you tell us at what time Curiosity touchdown, Earth received time, and at what time the first image came back?
First of those is 10:39 p.m. The second of those I don't have. It is a new architecture, and frankly, it looks crazy. It looked weird. It looked scary. Very crazy, wacky thing. And it looked like that to the folks at NASA headquarters. And so we went through what ended up being close to 2 hours. There's lots of questions, there's probing.
They ask about the airbags that worked so well last time. But this rover is 5 times heavier. Airbags would have to be impossibly huge. So that's out. What about a traditional lander with legs?
Legged landers, a la Viking.
With a heavy payload, it would be unstable, especially if it happened to land on a slope.
And that's one of the reasons that we don't like it.
The sky crane, though, can drop the rover anywhere it can drive.
It utilizes the rover's inherent terrain hugging capability. And the rover is placed in a condition ready to rove.
By the end of the day, the head of NASA was convinced.
He says, well, you know what? I came in here thinking that this was the craziest thing that I'd ever heard of, and I still think it's crazy. But I think it might just be crazy enough to work.
You take something that you think you understand, and you say, let's do it bigger. Let's not make it twice as big, let's make it 5, 10 times as big. Now you get to a whole new realm of complexity that we had never faced before.
Like this clears a bell in the sky. It happens like that in Houston too.
One's going to be out of the west for the next 4 days. We're going to burn. That way everything goes to the east side. And it did really good.
Ready? Hey, someone in the back watching? What are we doing? Just twisting around this way. Yep.
Yeah, and the 87 will do that. Yeah, 41 is just there. Or
Stick them into the right.
Guys, don't forget the crane's gonna. Good. Like that?
Nine,